topic is understanding config map and secrets, and we will also discuss Kubernetes Gateway API, its benefits, drawbacks of Ingress, and everything in between. But first, let's understand what is a config map. A config map is an API object used to store non-confidential data in key value pairs. We can think of it as a centralized configuration file that our application can read at runtime. This is best for environment variables, port numbers, file path, or entire configuration files like nginx.config. Why do we use it? It allows us to keep our container images clean. We can use the same image for development, staging, and production simply by swapping the config map attached to it. Both config map and secrets have same purpose of storing data, but config map is to store non-confidential data, whereas secrets is to store confidential data. What do we mean by non-confidential data? Non-confidential data is the data that is simply non-confidential. For example, that is environment variables, port numbers, file paths, configuration files that is stored in key value pairs. Simply, it is like a centralized configuration file that the application can read at runtime, which allows us to keep the container image clean, and we can use the same image for development, staging, and production by simply swapping the configuration map or config map attached to it. In short, config map is to store non-confidential data in key value pairs. Now, what is secret? A secret is a similar concept to config map, but it is specifically designed to hold sensitive information, which is best for passwords, OAuth tokens, SSH keys, and database credentials. The difference: while config maps are stored in plain text, secrets are stored in base64 encoded format. We can note that base64 is encoding, not encryption. For true security, we should enable encryption at rest in our cluster at etcd storage. So as I mentioned, secret is a similar concept to config map, but is to store confidential information or sensitive information, that is like passwords, tokens, SSH keys, database credentials. Config map can store data in plain text or is stored in plain text, whereas secrets are stored in base64 encoded format, so it is difficult or it is somewhat confusing to decode, which is better than plain text. Which is to note that base64 is not encryption. For true security, we should be implementing encryption of the cluster storage at etcd. Summary would be: the feature purpose of config map, that is configuration settings, whereas for secret it is sensitive or confidential data. For storage in config map, it is plain text, that is key value. For secret, it is base64 encoded. Example data: for config map it is log level debug, whereas for secret it is TB password, base64 encoded password. Size limit: for config map it is 1 MB, for secret it is 1 MB. So that was about config map and secrets. Now we will understand what is Kubernetes Gateway API, drawbacks of Ingress, and how Kubernetes Gateway API is more efficient and solves issues that were happening in Ingress. The core purpose: the Gateway API's purpose is provide a standardized, role-oriented, and expressive way to manage service networking. Instead of single all-in-one configuration file like Ingress, it breaks networking down into distinct pieces that match how real companies operate. This ensures that a developer can change an application route without accidentally breaking the entire cluster's load balancer settings. So first, we must know that Ingress is not bad or it is not too efficient, but we can understand Kubernetes Gateway API as an upgrade or a level up to the Ingress simply by enhancing or fixing what Ingress was lacking. So Ingress in itself is a major success in solving a lot of issues that were already present, whereas Kubernetes Gateway API is a level up or an upgrade to what Ingress was offering and its drawbacks. That being said, the core of Kubernetes Gateway API is to provide standardized, role-oriented, and expressive way to manage service networking. Where Ingress was all-in-one configuration file, Kubernetes Gateway API breaks into distinct pieces that match how real companies operate. That ensures developer can change application route without accidentally breaking entire clusters load balancer settings, which is operated by platform engineers or senior to the developer. Now let's understand what is critical drawbacks of Ingress and how Gateway API solves them. A, that is the annotation hell, lack of standardization. The problem, Ingress only supports very basic routing. For anything advanced like URL rewriting, header-based routing, or rate limiting, we had to use annotations. For example, nginx.ingress.kubernetes.io/rewrite target. This is for one annotation. If we had to use many annotations, that would look a lot larger. The impact, these annotations are vendor specific. If we move from Nginx to AWS, ALB or Istio, our configuration would break completely because they use different annotations. The solution, Gateway API build these features into the core specifications. Features like header-based matching or traffic splitting canary deployments are now native and portable across different providers. So the problem in Ingress is that it supports very basic routing. For something advanced or more enhanced production features like URL rewriting, header-based routing, or rate limiting, although it is supported, but we had to use annotations like this syntax, which is really large or long. Also, these annotations were vendor specific. If we moved from Nginx to AWS, ALB or Istio or to different vendors, that configuration would break completely because they use different annotations. Solution is that Gateway API builds these features into their core specification. Features like these header-based matching, traffic splitting, that is canary deployments, are now native and portable across different providers. B, that is the monolithic configuration, that is role conflict. The problem, an Ingress resource combines infrastructure, that is TLS certifications, load balancer settings with application logic, that is URL paths. The impact, a developer who just wants to add new/API/v2 path needs permission to edit the entire Ingress object, potentially giving them power to accidentally delete a TLS certificate or change a global load balancer setting. The solution, it introduces role-based separation. Gateway class managed by infrastructure providers, that is the AWS load balancer type. Gateway, that is managed by cluster operators. For example, we define the port 443 listener and TLS certifications. HTTP route managed by developers, for example route/app to my service. The problem is that Ingress is monolithic in nature. For example, the Ingress resource combines infrastructure with application logic. So that would mean a developer who just wants to update something simple or not so complex would need permissions to edit the entire Ingress object. Potentially that would give them power to accidentally delete a TLS certificate or services or task managed by platform engineers. In short, a developer who just needs to manage simple tasks in an Ingress object would have all the permissions to potentially manipulate or accidentally manipulate those details that is actually needs to be managed by platform engineers or senior DevOps engineers. So the solution for this is that Kubernetes Gateway API introduces role-based separation. For example, Gateway class would be managed by the upper or the senior platform engineers, and they would manage all these like role balancer type, and Gateway is also managed by seniors, and HTTP route would be managed by developers. So it would provide role-based separation. So every role would be redirected to certain separation. They would manage only that and does not accidentally manipulate or change other resources. C, that is no cross namespace support. The problem, Ingress usually requires the Ingress resource and the service to be in the same namespace. The impact, this makes it extremely difficult to manage a shared gateway where one central load balancer serves multiple teams in different namespaces. The solution, Gateway API allows cross namespace routing, and HTTP route in namespace A can securely attach itself to a gateway in namespace B using reference grant for validation. So problem is Ingress usually require Ingress resource and service to be in the same namespace, meaning other namespace cannot be communicated, which makes it extremely difficult to manage shared gateway where one central load balancer serves multiple teams in different namespaces. Basically, Ingress in namespace A cannot communicate to the services in namespace B. So we would think that why did Kubernetes build this in that way? The main reason is security. It was intentional choice to prevent traffic hijacking. For example, if any developer could create an ingress in their own namespace that points to a service in another namespace, they could accidentally or maliciously steal the traffic. And by forcing ingress and service to be in the same room or in the single namespace, Kubernetes ensures that whoever is configuring the door, that is the ingress, also has the permissions to manage the room or the namespace. So Gateway API solves this problem that Ingress had by allowing cross namespace routing. For example, a HTTP route in namespace A can securely attach itself to gateway in namespace B using reference grant for validation. Reference grant is like a permission that would allow this to work. Delimited protocol support. The problem: Ingress was designed strictly for HTTP or HTTPS. The impact: if we needed to route TCP, UDP or gRPC traffic, we often had to bypass Ingress entirely or use even more complex vendor-specific hacks. The solution, Gateway API, is protocol agnostic. It includes specific resources like TCP route, UDP route, TLS route, gRPC route right out of the box. The problem in Ingress was it was strictly designed for HTTP or HTTPS routing. Now, if we needed to route with other protocols, we needed like TCP, UDP or gRPC traffic, we often had to bypass Ingress entirely or use even more complex vendor-specific hacks. The solution is that Gateway API protocol includes specific resources like these right out of the box, meaning it supports other protocols for routing. So that was about drawbacks of Ingress and how Gateway API Kubernetes solves this. Now let's understand advanced traffic control, which is like the benefits of Kubernetes Gateway API. First is header-based matching, that is request routing. In a standard Ingress, routing is usually limited to host, that is example.com, and path/API. Gateway API allows us to route traffic based on any part of the HTTP request. The use case would be A or B testing or internal beta testing. How it works: we can tell the Gateway API to route traffic to our experimental service only if a specific header is present. For example, X user type or beta tester. The logic would be if the header version is v2, route to v2 service, otherwise route to v1 service. In standard Ingress, routing was limited to host or path, but in Gateway API, it allows us to route traffic based on any part of the HTTP request, which is basically used for A or B testing or internal beta testing. We can tell Gateway to route traffic to experimental services or features if the specific header is present. For example, X user type, which would be like a VIP user or a standard user, that can be anything subjective to the developers that would route traffic to the beta tester. So the logic would look like if the header version, that is v2, that would route to the v2 service, otherwise it would route to the v1 service. Second is traffic weighting or canary deployments. Weighting allows us to split traffic between different versions of a service based on a percentage. The use case: blue-green or canary deployments. The logic: instead of switching 100% of our users to new version and risking a total crash, we can define a split. For example, configuration would look like service A, that is stable, would have weight 90 and service B, which is new, would have the weight 10. As we gain confidence in the new version, we incrementally increase the weight of service B without ever changing the DNS or the load balancer IP. So I think it is simple. If there exists a new version, we would not want to risk total crash, so we would be splitting the traffic with respect to users. 90% would be on the service A, that is stable, and 10% would be, that is like a weight 10, would be in the new version. It is to test or to gain confidence in the new version. If we feel that the new version is secure and we gain confidence, we can incrementally increase the weight of service B or completely move traffic to the service B and make it 100% without ever changing the DNS or the load balancer IP. Third is filters, that is request or response manipulation. Filters allows us to modify the traffic as it passes through the gateway before it even touches application code. This keeps our application logic clean. There are three primary types of filters. A, that is request header modifier. The purpose It is to add, set or remove headers before the request reaches the backend. For example, automatically adding a X forwarded client IP header or stripping a set cookie header for security. By default, the traffic that we receive in the backend is messy, or it misses key piece of information that a backend service needs to do their job. So the request header modifier would add, set or remove headers before the request reaches the backend. So before the request reaches the backend, we can add somewhat like a rule for us to know specific information before it reaches the backend. For set, it would look like setting the traffic with respect to the users. That is, if the users are gold member, so the request would treat that user accordingly. And if the user is standard, the set rule would treat that user accordingly to the standard. And for remove, simply it is to manage security and ensure that we follow compliance rules. If the traffic that is to be received in the backend contains sensitive information, that is passwords, social security number, etc., this rule that is remove would scribble over that sensitive information so that the backend inside cannot see it. So it keeps the data secure and prevents the backend from seeing things it shouldn't. So you would think, if the backend is owned by us, and why do we need to remove such sensitive information reaching the backend? First, a malicious user can still fake the header for user admin, that is true, and if the backend treats that header as true, it can be hacked to have sensitive information. And many backends or tools crash or behave weirdly if they receive unexpected headers or huge amount of cookie data. So this gateway acts as a filter, so the application only receives exactly what it expects. And also there is the privacy issue or GDPR or compliance. We would want to strip out tracking cookies or personal info at the front door, so the internal logs and database never accidentally store sensitive data that they don't need. Now B, that is request mirroring, that is shadowing. Purpose: this is a silent filter. It sends a copy of live production traffic to a test service. The impact: we can see how our new version handles real world load and data without the test services response ever reaching the actual user. The user only sees the response from the stable version. So request mirroring is a silent filter. It sends copy of the live production traffic to a test service or a beta service or a new version, so we can see how the new version handles that real world load and data without the test service or the version service response ever reaching that actual user. The user only sees the response from the stable version. C, that is URL rewrite or redirect. The purpose is to change the path of the request on the fly. For example, a user request that is example.com/shop, which is https example.com/shop, but the filter silently rewrites it to /version3/commerce/shop before sending it to the backend pod. This is when we have updated the version of, for example, that is /shop to the version 3. Instead of changing the folder structure and redeploying the code, it simply rewrites the new version path to the existing path. So if example.com/shop is a older version or is simply version 2, and we have new version that is version 3 that has the path version 3/commerce/shop, instead of changing the folders and redeploying the application, we simply redirect that path to the existing path without needing to redeploy and change the folders, etc. So that was about advanced traffic control and its features provided by Kubernetes Gateway API. Now let's understand the summary of it. Feature that is primary focus: for Ingress, it is simple HTTPS routing, whereas for Gateway API, it supports layer 4 TCP or UDP and layer 7 that is HTTP or gRPC. Feature that is resource model: for Ingress, it is single resource Ingress, whereas for Gateway API, it is modular gateway class gateway routes. Feature that is portability: for Ingress, it is low. It relies on vendor annotations, whereas for Gateway API, it is high. It standardizes across different controllers. Feature that is role separation: in Ingress, it is none. Everyone touches the same file and can manipulate that Ingress file, whereas for Gateway API, it is explicit: infrastructure versus platform versus developer. Feature that is traffic control: for Ingress, it is basic path or host, whereas for Gateway API, API, it is advanced, that is header matching, weighting, filters. So that is it for the video today. Thanks so much for watching. Have a great day. Bye.